in October last year, about a year ago, we released 9.2.1, and fairly recently we released that's been a fairly stable compiler. We continue to update that. 9.4 has just come out, or it's just coming out. Has it just come? No? Yes, it has just come, right? And 9.1, planning 9.6 in about 6 months' time here. So this will be, you can see a bit about what's in each of these here. So 9.2, what happened in 9.2? Well, one thing is we did this Ghc 2021 flag, which was the result of a Ghc proposal. I'll say a little bit more about Ghc proposals later. So now, with a single -x Ghc 2021, you get all of these extensions, this cornucopia of wonderfulness. And fortunately, this is not what, as the Ghc design team didn't need to work on, this is the steering committee and the proposal process told us what this list should be. So, for what it's worth, that's a convenient way to sort of embody the things that a lot of people seem to be using and that they're somewhat stable. Okay, let's see. 9.2 was the time when finally we got impredicativity. This was after, was it 4 papers in succession? All like Hopple and ICOP papers. This is the way to do it. And then 3 years later we said, no, this is the way to do it. Finally, quick look and impredicative polymorphism. So this lets you makes you make polymorphism more first class. So we can now have lists which contain polymorphic things. You can just put a polymorphic type wherever you can put an ordinary monomorphic type. And that seems like simple and obvious thing to do, but incredibly hard. But now it turned out to be a nice compromise. So and we are pleased to try it out. Let us know if it works. I've had remarkably few bug reports about it, which I think is for me, that's usually either tells me nobody's using it, or it tells me that actually we finally got it close to right, so the implementation was not too far off. Much more controversially, Haskell records and the power of the dot. But yes, finally, so Neil Mitchell and his crew at was it Standard Chartered at the time? Had no, he knew. Was it? It was what? Digital asset. Digital asset. It was digital asset at the time. They had a whole fork of GHC, and they forked GHC to get this one feature. Right. So now you can write het.name to do record selection. Ooh, quite why it took us 20 years to do this, I don't know. But here we go. So this is, I don't know what you think. I think this might have quite a big effect over time. Deep subsumption was so this is not in the 9.2.1 as released a year ago. This was because as part of the work on impredicativity, you may remember that I wrote a proposal that said we should give up on what's called deep subsumption and move to a simpler system called simple subsumption. And everyone, the Ghc steering committee said, yes, that's fine. And then a year later, after we'd released this, when finally everybody updated their libraries, everyone said, no, that's breaking too much of our code. Every breakage can be fixed, but it is passive to fix. So there was a lot of feedback in the community. I ended up putting back in, there's now a deep subsumption flag. Essentially, it recovers the old behavior, but at some cost to how much you get from impredicativity. So I regard it as a misfeature, but you're welcome to use it, and it works perfectly serviceably. It's not a grotesque hack. It's just one more thing. Okay, but it's an example of the feedback loop, operating for a fairly long time ago, actually. Okay, what else? Unlifted data types. So this is not. Were you involved much in unlifted data types, Joachim? Were you involved in designing this? No. So as time has gone on, as you know, that Haskell is a lazy language, so every data type contains bottom, except some, like int hash, which doesn't contain bottom, just contains the unboxed integers. But the only things that were unlifted were also unboxed. Oh, except that we had one built-in type, Arrayhash, which was boxed because it was heap allocated, but unlifted, meaning it was, when you had a pointer to it, it was always a pointer to the array itself, never to a thunk that would evaluate to the array. Right? So it means you're programming entirely with values, not thunks. And if you really care about efficiency, that can matter. So now you can declare in the kind signature. Oh look, separate kind signatures. I didn't mention this. Maybe that was in 9.0. You can write for a data type declaration, you can, just as you can write a type signature for a value declaration, you can write a kind signature for a data type declaration or a class declaration. Here's the one for static strip maybe, and it returns a unlifted type rather than a type. And that says that every value of type strip maybe is we have to use call by value for it, obviously, because there are no bottom values. So foo will always use call by value. So inside the code for foo, this case expression doesn't need to do any value. Okay. Yeah.
So what about the value inside the just?
Oh, what about the value inside the just? Oh, this guy here, he is still a fully arbitrary type. Yes. So he might be and his kind says whether he's lifted or unlifted. So this guy silently behind the scenes has kind type, right? Meaning lifted types. Right? This A, but you can say open paren a colon. Shall I do it? Can somebody hold the microphone for a second? Thank you very much. You can be my lectern. Can we do this? Can I manage this without my glasses? Joachim, you tell me if I get this wrong.
You can see it.
Oh, come on. That's weird. Okay. In that case, that is a problem for later. What happens if I do this? Okay, now you can see it again. That's a little weird. Okay, well, what I was going to say is a colon type written in capitals, unlifted. Right, that would say A ranges over types that are not lifted, and then indeed this guy A would be an unlifted type.
Simon, can I just put unlifted type as the parameter in the kind signature? Would that be sufficient?
As the parameter in the kind, where?
Strict maybe takes unlifted type to unlifted type.
Oh, A colon unlifted type.
In the kind signature. Why not?
Yes.
Yeah.
Oh. That would have been a lot simpler. I knew there was a reason that I had a room full of intelligent people to LinkedIn. Yes, that would be way simpler. And that, if that doesn't work, that's a bug. So just give it a try. Yes. So unlifted type to unlifted type. Yes.
So are there expressions of unlifted types? Yes, there are. If so, can they use recursion?
Yes, there are expressions of unlifted type. Yes, they can use recursion. So we already have int hash thing. Right? So you can have a function that returns an int hash and a recursive function that returns an int hash. Yes? And a recursive function that takes int hash arguments, and that uses call by value. So that sort of gives you, puts you into the world of ML rather than Haskell.
When a function is applied to an unlifted type, then function application means it.
Yes, so when a function is applied to a value of unlifted type, we use call by value. So just like int hash, if I apply a function to an int hash, I can't pass a function. Must use call by value. So yes, using unlifted types essentially pushes you into the call by value. So Haskell is gradually, creeping, quietly, and becoming ML. Yes. Oh, sorry. Yes.
Question. So you get a function that takes an unlifted data type argument, but the result type is lifted.
Yes.
The application itself is still going to be lifted, right?
Oh wait. So if a function takes, so let's just stick in the world of int. If it takes int hash to int, say, then if you have an application f of 3 hash, say, well that is a type int, so that's lifted. That's a func, right? You put that inside a data structure, won't be evaluated. Well, you do, but if it was f of 3 hash plus hash 4 hash, right? Then that bit isn't suspended. So when you evaluate the call to f, the whole thing, then you evaluate it. So the calls to f will be. Yeah. Does that make sense? Okay. Yeah.
Can you be polymorphic over whether?
Can you have polymorphism over liftedness? Oh, great question. Yes. So what happens in a call? If at the call site you can't tell whether it's lifted or unlifted, so yes, you can have polymorphism. It's called levity polymorphism. We have a whole paper about it. It's on my homepage. But at any particular call site, it must be statically known whether that is lifted or unlifted. So, and that is that's a property of the core language type system. At every call site, you must know. But it turns out that is not the same as saying you never get levity polymorphism. You can make levity polymorphic things, and usefully so. The paper describes how. But at every call site, you must know because we're going to generate different machine instructions. Yeah.
Do we allow infinite strict types? No,
Oh,
I guess.
no, an infinite strict type. So if you said, data, if this guy, this strict maybe here, had another field here, strict maybe, right? You could do that, but then you better, then it will all be about, it'd be like an ML list. It will all be evaluated, and you better get to an S nothing at the end, right?
But doesn't ML allows infinite structures, doesn't it?
You can also create them via recursion.
Slowly good.
Oh,
It's rarely.
oh, okay. You can create infinite structures, maybe. Pass. That's a good question. I don't know whether we've implemented enough to build. I think it's likely to just work. But you're saying if you have an infinite stream, no S nothing, but an S maybe here or something, and you want to build one of those statically. I've run out of cycles to compute whether that would actually work today. But it would work in an ML compiler, would it?
It will work.
Oh, wow.
Really?
Yes.
Okay.
It's a complicated.
Okay, well, by the end of the talk, I expect somebody to have tried this. Right. Yeah.
What is the difference between strictness annotations and unlifted types?
What is the difference between strictness annotations and unlifted types? So, a strictness annotation, well, for start, that doesn't show up in the type system at all. That is in, you might say, let bang A equal something. But I do think it'll allow us to explore the call by value, call by name, call by need space quite a bit more. Okay, what else? Quite a bit of other infrastructure has taken place. I have nothing to do with this. This is led by Alan Zimmerman, but a lot of other people have done this. So if you want to take a Ghc syntax tree, and then print it. So we have to decorate the tree with a lot of extra information. Previously, that was kept on the side somewhere in a separate finite map, but now it's part of the syntax tree in the so-called extension fields of each constructor. So that's using this trees that grow idea, but now that's been pushed through very far. So there's a Ghc syntax tree now that makes extensive use of these extension fields, which is a bit head-scratching when you see it for the first time, but you get used to it. I'm slowly getting used to it. So lots of work there. And this is great for the HLS thing. Am I right? Yes, helpful for that. Tamar has been doing a lot of work on Windows I/O. So I don't know if that's probably. Are there any Windows aficionados here? No, see, so you won't care. None of you will care. But if you're a Windows person, then using Windows POSIX emulation. I don't care anymore, by the way. No, I'm still using Windows machine, but I'm using Windows subsystem for Linux. So anyway, but if you do use Windows, this is a pretty significant piece of work. Tamar is amazing. Been working on it. They've been working on it for a long time. So quite a lot of improvements in profile, and I want to just mention to you because I don't know very much about them, but I think they will. This is largely driven by the requests of end users, and actually often paid for by companies. I think this particular piece of work was paid for by a company. So this particular one is a kind of improvement to low-level profiling. So this for this, you don't need to. Let's see if I got this. What was I? I think I put the screenshot in the wrong place. You don't, for this profiling mechanism, you don't need to compile with -prof or anything, right? You just can use an unmodified binary. You can add some extra flags as you do compile that adds a bit of extra metadata that gives you more information, but you don't have to. And then what you get is things that look like this. Now, what is this telling you? This is saying for it tells you both for cumulative allocation and for snapshots of allocation. So this is a graph through the life of the program. It says for every allocation site in the program. So if you look through the source code, like when you see a let, I'm allocating a thumb. When you see a constructor application, you're going to be allocating a constructor. For every static point in the source code where one of those is happening, where some allocation is taking place, there's going to be a line on here, and it's going to show you the residency of data allocated at that single site and the total integrated size. Integrated means total. it's a complicated way of saying total. That says how many megabytes in total were allocated at that site. So if you've ever used Tiki profiling, it's a little bit like this, but this is much more visual and also gives you these sort of lifetime stuff. And there's various flags that mean you get a bit more information about. If you don't add the flags, you get fewer of these intermediate columns that tell you where you just get a sort of some kind of machine address. By adding the extra metadata, you get a bit more source code related information. So I think this is really helpful when debugging. Where is my space going? If I've got high residency, who's allocating at least? This isn't retainer profiling. It doesn't tell you why it's staying alive, but it's a lot better than what we had. This is all Ben Gamari's work, by the way, but I believe paid for by a very generous and clearly needy sponsor.
Does it do time profiling as well?
That's a good question. How much time would be spent at the site? I mean, I don't think so. But I will try to send you something about. There's a second profile I think to tell you. Yes.
Doesn't mean you get profile information to happen something where some packages that are used have not been compiled.
Yes. So you don't need to compile. If the packages you're using are not being compiled in a magic way, you'll still get all this profiling information. But I think I think you may, it may say somewhere in that package there was a, constructor. I don't know anything about it because you haven't got that metadata.
Right, but if you're working on a particular piece of code and you supply the right flags when you compile that code,
Yes.
now you can get information about.
Yes, you get information about your code. Yes. Even though it's using package. Yes. So the allocations in your code will be well displayed. The allocations in the other code will be badly displayed, but they'll be compatible. Right. You can run it. So that's the sort of crucial thing is yes, you do not have to I didn't say it. You do not have to recompile everything with a different flag. Yes. Super important. Yes, thanks. Okay, but more profiling. And so this is in 9.4. There's another chunk of worker profiling which I put here. This is called late cost center profiling. Do you remember the cost center stuff that does tell you who calls who? And as things stand, that's added right at the beginning. The sort of infrastructure for that is added by way of so-called ticks in the core code right at the beginning of the pipeline, precisely so that what you get is a profile of the program that you wrote. But of course, to maintain that information gets in the way of optimizations, right? So in your profiling, something that closely relates to your source code, but maybe that something doesn't so closely relate to the code that you're finally going to run. So that's bad. So instead, Andreas has implemented this variant of cost center profiling that says run the whole optimization stack and then add cost centers. So then what you get is cost center profiling that tells you who calls who, and then spends a lot of time, right? So then we're back to time profiling. So to interpret those who calls who, you're going to have to know the output of the optimizer. You're going to have to do a bit of looking at simplified core, but it doesn't interfere with the optimization pipeline. So what you measure is what you're going to run. Yes, Joe.
Is that just the optimizations in core, or does it actually insert it after SDG? And
I think I don't quite know.
I'm pretty sure it's after core.
I think it's after, at the end of core. It's maybe at the end of core prep, but so there's a little bit more that happens in SDG, but really not much. Right? Not much. And it's all to do with changing representations. There's no inlining or large scale movement of
Common for expression.
there is some concept expression. Yeah. You should go tell Andreas he's got to move it later still. And then also, it turned out there was a sort of minor problem with cost center profiling, minor, but important for really minor in some senses, but super important for some people, which is that it didn't really tell you, this is for retainer profiling, it didn't tell you about how much data and who was retaining pinned objects. And sometimes, for some applications, pinned objects is really important. So, we fix that. That's in 9.4. So profiling generally is significantly better in 9.2 and 9.4. And I encourage you to give those a whirl. But because it's a first iteration, I'm sure there are improvements to be made. Any more? No. Okay. Plugins have proved to be, as unsurprisingly, as an extension point for GHC, have proved to be very popular because people can then make GHC do things it wasn't designed to do at all, which is always the hallmark of a good modular thing. But of course, the design of plugins has evolved. What plugin books do you have? And there are at least 3 different extensions here to the plugin infrastructure that have been made during these, actually in 9.4. So I have nothing to do with these, I don't know very much about it, but thank you to the people who did it. And do give it a whirl. Has anybody been involved in any of these and wants to say anything about it? No, as it happens, not in the room. Okay. I've been quite involved in lots of optimization stuff. Mostly incremental, no big optimization changes, but programs are steadily getting a little bit faster, often in particular corner cases. So Sebastian Graf, who used to be Joachim's research student and is wildly productive, been working on demand analysis a lot, and that interacts with boxity analysis, which is figuring out when you want to unbox things and not when they're strict. Andreas has been working a lot on figuring out when we can omit tag checks. So this is a back-end question. Do you remember I said when that type is unlifted, we know that it's evaluated, so we don't need to do the eval. Well, sometimes there may be more situations, and when we know that, we also may know that in the pointer to the object, usually suppose you have a pointer to a list, right? When you point to a list and you want to do case analysis on it, you could say, well, I'll follow the pointer and find out whether he's a nil or a cons. But in fact, the pointer to a list often contains, in its least significant bits, a couple of bits that say whether it's a nil or a cons. So then you don't need to follow the pointer to discover that it's nil. So this is called pointer tagging. And of course, it makes things go a bit faster, and sometimes means you never need to follow the pointer, so it reduces memory, reduces memory load. So that's really good. And Andreas has found ways of making sure that we can get those tags into the pointer. So the garbage collector, as it were, it makes every pointer to a data structure. It adds the tags into the pointer. So adding tags into the pointer is kind of optional, but the more you can do it, the better. Garbage collector does it, and Andreas has made it so that we more often have fully tagged pointers from birth, and that we know that they're fully tagged, particularly in data structures that are strict. So the poster child application for this is a tree in which the children, the child nodes of a branch node, are marked strict, right, with a bang. Sorry, where was the bang person? That is one place you can have a bang in a data type, is in the fields of data constructors. So in that case, from birth, the pointer to the child object, since it's strict, is going to be a pointer is a fully tagged pointer. And that turned out to make a truly significant, like a 5 or 10 or 15% difference to the speed of some, finite map kind of implementations. I was surprised that it was so much, but I tried to measure it. So anyway, I'm excited about it. Nested constructed product result, that's also Sebastian. It sort of goes with boxity analysis and lots of other things, particularly parity. I've spent a lot of time on parity analysis. Has anybody else been working on optimizations they want to tell anybody about? No, maybe you're all customers. Back to levity polymorphism, which we were talking about. So as part of, again, another Ghc proposal, in the kind system, here we are. So here is a kind signature for Arrayhash. Right, so Arrayhash is a type constructor, and its kind is for all levs of type levity, it takes it returns a type, but what's its argument type? So remember, Arrayhash is going to take a type like a type to a type, but what kind of type does it take? Well, it takes one that is boxed. So Arrayhash only takes box types. That is, box means represented by a heap pointer, but the box type can be, well, lifted or unlifted. So here really is a live example of levity polymorphism in the kind signature of Arrayhash. So what's levity here? Well, it's just an ordinary old two constructor data type, and runtime rep, which is the argument to this capital type, is an argument of type runtime rep, and runtime rep is an algebraic data type which has things like int rep, that's the representation for int hash, and word rep, that's the representation for word rep, and int 8 rep, that's the representation for 8-bit integers, and so forth. So there are about 15 or 20 runtime reps. Yeah.
So then how is unlifted type defined? Is it
Oh,
a type synonym?
Unlifted type, yes, that thing that's spelled UNLIFTED all one word, is a type synonym for capital type of boxed rep of lifted. Yes, it's just a type synonym. Yes. So yes, and then it turned out that we used to have oh, that's right. So arrays used to be even primitive arrays used to be things of type you would say array of A, and A could only range over lifted types. So if you wanted an array hash of array hashes, you couldn't have it because the kinds didn't work, right? Because the inner array hashes were unlifted, but array hash thought it took lifted things. But now array hash can take lifted or unlifted things. So we can get rid of two different type constructors and replace it with one polymorphic one. That's very nice. And and of course, since there's a lot of primitive operations like indexing and making these things bigger and smaller and so forth, there was a big saving in primops. Okay, so this is a nice generalization. Can be pretty consistent. Yes.
I don't think it's supposed to be user or is it only for me?
Are these supposed to be user oriented?
Are these exposed to me?
Oh yes, they're exposed to the user. I mean, of course, it depends on the user. You have to, if you just import Prelude, you may not. I don't think you're going to get levity if you just import Prelude, for example. I think you have to, you're going to have to import ghc.ext or data.kind or something. Indeed, the whole design of exactly what the stable API and what the unstable API is, but it's very much meant to be this is meant to be a sort of stable, repeatable, usable part of Ghc when you want to write fast code. Yeah.
So if you have an array hash of an array hash, does the memory representation get flattened?
No, it does not. No. So array hash of array hash will still be represented by array of pointers to arrays of pointers. So that would be quite cool to. If you want to do that flattening, you need to do some, do you remember that data parallel Haskell project? We could never quite make that systematic global flattening transformation work. It was just it blew my complexity budget in the end. So, but that would be a good thing to work on, particularly array hash of unlifted pairs. That would really be a good thing to flatten, right? So, yeah.
Is code duplication happening if we have different parameters for that?
Is code duplication happening if you have different parameters for levity? So at one point, so there is only one, array hash data constructor. But if you, as we were saying earlier, if you write a function that takes an argument, it cannot be a polymorphic levity, right? Because we've got to generate different machine instructions for the call. So it's still monomorphic at the call sites. I suppose the answer is yes, you get code duplication when different machine instructions would be generated. And that's reasonable because then it's not duplication, it's different code. Right?
But it's basically focused on the call side and not on the definition.
Yes, that's right. Yeah, also, so the only thing what I would love is to be able to write definitions that look levity polymorphic and have Ghc crank out two copies, one for the lifted and one unlifted. We can't do that yet, though. Yes. Yeah.
So am I reading the kind signature of array hash, right? The array hash of whatever is itself a lifted box type?
Yeah. No. I think I've probably written down this kind signature wrong. Array hash. No, I should have said unlifted type. Thank you. Yes. Array hash itself is an unlifted thing. There's array, which is yes. Thank you. I think it's just a typo, but maybe. You can consult the Ghc source code to find out for sure. Yeah. Okay. What else? Make is finally dead. Even I've switched. I was the last person to switch. I've switched to Hadrian. More windows, better linking. I think these are things that are very much driven by. But I think the Windows is switching tool chain. So that's quite a big change actually. Instead of the MSys or Mingwa toolchain, we're now using Clang toolchain. This linking against C++ was, I think again, this was probably provoked by some practical applications to work on here. This I'm dead keen on. Why haven't we had this before? So so in Ghc you're meant to check in Haskell code the bounds of bounds checking for array operations, and of course array ending does do such a check. But the primops themselves are unchecked. So if you screw up on your bound checking, bad things can happen. So this says, and we'll generate code that does do the bound checks, even of the primop, so that you can check that you haven't screwed up. It's a sort of belt and braces. Of course, if you have got a bug of that kind, it's really helpful to have it found like this. Okay? And we worked quite hard on improving compile time and memory time. I would say that if I'm doing something in GHC, about half my time is spent, making the change. The other half is spent looking at, in one of these 200 benchmark programs, compilation time has gone up by 3%. I wonder why. As when I look at it, I say, we're generating more code. That's common. Or it could be, of course, it could be that the compiler itself has got slower. That'd be annoying. Often it's that we're just generating a bit more. So it's quite a big extra tax on implementers to look at these performance regressions, but it helps to stop the inevitable drift of increased compile times. So what can I say? We're trying. We're investing real personal cycles, and lots of people are, in improving compile time. And actually some of them have gone down quite a lot. Okay. Error messages. So this is quite a big project. At the moment, GHC's error messages were generated. They're just strings, really. Well, SDocs, which are nicely formatted strings. But they had, any customer of the error messages was forced to essentially parse the text. Not very good, right? So now there's a big move to make GHC's error messages all be part of one gigantic algebraic data type, in which every error message has its own constructor. It is a huge engineering effort to do this. And it's part of some more error message infrastructure we'll talk about in a little bit. But I just want to say there's a big chunk of stuff going on here. It's a bit incremental, right? So at the moment, one of the constructors is go back to the old way, and here's an SDoc, right? So, but there's quite a lot of work to do to gradually move all those SDocs into this new world, and we could do with help with that. Okay, so much for 9.4. How are we doing for time? Good. Oh, no, this is bad. When do we start? When do we start? No, we start. Oh, that's fine. Yeah, okay. So no, we have 45. Good. Okay. What's happening? So things that are happening in 9.6, there's a little preview, what's going on. So a huge thing is getting a WebAssembly and JavaScript backends, and people are working Cheng and Silvan, and actually many others are working pretty hard on this. And Norman, in fact. Do you want to say anything about this, Norman? Because I know very little about this project. What are the challenges? What are they? Are they trudging up the hill? Is it full of excitement? Absolutely.
I'll just say about one challenge with the WebAssembly, and that the standard for WebAssembly doesn't cover separate compilation. And so Chung has picked up some technology for separate compilation from Clang and LLVM, but it's not quite documented, and it doesn't quite work the way it is documented, and so on and so forth. So the big challenge there is separate compilation.
Right. Okay. Well, this would mean that we could run GHC programs and GHC compile programs in browsers. It's pretty amazing. But it's a big stress test for the entire WebAssembly infrastructure, isn't it? Which is probably what you're saying, is that we're stressing bits there. But yeah. Okay. So I'm sure they'd be thrilled if more people wanted to join in. Hands up.
So
in fact, did I see Andreas? Yeah, there he is. Right. Is what Norman says true? Is he casting aspersions on WebAssembly? Should have.
No, separate compilation is always one of the kind of topics I argue about at the working group, where nobody else cares about it.
Oh, but now you've got a client group that cares about it.
Exactly. So yes. I want to talk to Norman about that and hear his experience.
Right. Yes. So you have a nice, eye-to-eye conversation. This is what ICFP is good for, with haptic feedback. Good. Lots more cross-compilation, exception backtraces. Alexis, do you want to tell us about delimited continuations? Where are you? Yeah.
I mean, there's not really that much to say. I think that the implementation is not quite merged, but I think it's basically been approved. I think somebody mostly just has to click the button. I think there's like one minor change that I wanted to make, but it's basically there. There's still no real user-facing interface to it that's safe. just because of the fact that it runs in I/O and arbitrary I/O computation is not reentrant. So we were sort of intentionally punting on that, but it should be relatively easy based on the design that we ended up with after a couple revisions of the proposal to implement a safe interface on top. And of course, there's a few different ways that you can do that. I have sort of an example of that. I have a couple examples of that, but I know that there's also some potential uses for this that some people have mentioned. So to be honest, I'm very interested to see what people actually use it for and if they get performance gains or not. The implementation right now is pretty naive from a performance point of view. So any feedback would be very helpful.
Yeah, and it had something fundamental, doesn't it? That
Yes.
we just couldn't do before.
Yes, but it was remarkably easy to implement, which I was very surprised by.
Only for a very intelligent person. so you know, I look at Alexis's proposal, I think, oh, Alexis, you know what?
I think the thing that was very interesting about it was that Ghc already has to suspend arbitrary thunks when an asynchronous exception is delivered. So there's actually already a bunch of code in Ghc to when because if you had to sort of abort a thunk and restart it, then you would have to keep around all the context. You wouldn't be able to garbage collect any of it. And so there was already some code in place to basically copy the stack into the heap for thunks. And so for that reason, it was remarkably easy to implement. So.
Yeah, so in fact, Simon Marlowe had implemented delimited continuations, but he didn't call it that. He just said, he just went, oh, it works, guys. Yeah, so I think it's pretty exciting. I think this is sort of Matthew, who has worked a lot on GHC. His thesis was about type template Haskell verse improvement. So I think he's planning to work on this. But this is actually close the WinIO loop. And John Erickson and a number of other people listed here. In fact, probably there's a longer list. Doing a big internal. This is not user facing at all. This is entirely within GHC's code base. Is sort of refactoring GHC's internal code base to more clearly separate like individual optimization passes and the flags that they need from the rest of the thing. So sort of coupling within the GHC code base is being reduced. Okay. More work on error messages. This would be a good place to David, if you'd like to tell us just a bit about these describing error messages and the error message numbering stuff. Could you? I put those two screenshots in for you. If you want to, shall I put?
Yeah. So if you all remember the big subtype with the error messages, there's now numbers for each constructor of the subtype, sort of carefully tweaked to match human perceptions of error messages. And at the Haskell Foundation, we are coordinating the construction of a community-run index of error messages. You can see a sort of an early preview here. Note that they're namespaced to GHC, so if you're making other Haskell-related tools and would like to describe your error messages here, get in touch and we will assign you your own namespace.
Instead of GHC, you could say...
you could say Cabal or... Yeah, I don't think HLS is going to make its own errors, but maybe... Okay. I don't know. Yeah. We'll see. Yeah. So then you can go in and you can take a look at your error message. Then let's say you click on one of those examples, then we can get some examples of where things go wrong and some descriptions of how to fix it. So, various programs that exhibit the error and versions of them that then do not. And hopefully this will make it easier for people who are using various features of Haskell to get things done. It's inspired by the Rust compiler's error message index, and most of the text was written by volunteers at ZeroHack. So far.
6,956. That's a lot of errors.
So Leonard says that's a lot of errors based on the large number. So the idea here was to uniformly sample them from the space of allowed errors rather than assigning them sequentially. And the thought process behind that is that if we assign them sequentially, then it happens to be the case that related error messages constructors occur next to each other in the code today. But then people may start getting an idea, oh, that's error number 2 in the 240s. That must be a parser error. And then we add a new kind of parser error, and it gets error number 380. And that could be confusing. And similarly, if you look at the Rust error message index, you note that the ones earlier in the list mostly say, this error is no longer emitted by the compiler. Whereas if you go later in the list, that happens less often. So I think that randomly assigning them avoids some of the sort of encodings of information that could be confusing.
more or less, each release of GHC, there'll be a new random assignment.
No, Simon. Simon says that each time we get new assignments. So actually, these are intended to be stable over time, so that only new errors get new numbers. And also, we reduce merge conflicts by people working on long-lived branches of the compiler by randomly assigning them.
Is there support for like other backends? For example, if I am writing the JavaScript backend, can I now add a bunch of JavaScript specific errors?
So the question is there support for other backends? Like if you're making a JavaScript backend, can you do that? Yes, please do that. And if you have questions about how to do it, then talk to me and I'll get you hooked up.
Time to make a Jira ticket.
Yeah, because the more the better.
And in fact, you're looking for, you've not completed all of this.
Yes. Simon says we have not completed all of them, and that's absolutely right. I think that there are something like 360 distinct error codes, and I think we've got about 60 of them documented so far. And if you'd like to participate, we tried to make it a sort of low friction process. So it's a Git repository full of Markdown files and Haskell files that are the examples, and then there's a script that converts it into a static website. So you can contribute even if you're not feeling up to GHC hacking yourself.
So,
obviously, the stuff in the box, is that regenerated? So with the next version of the compiler, that changes the documentation is still up to date.
So Leonard asks if the examples are regenerated automatically, and the answer to that is no, they are not, because these are intended as human communication to other humans, and we would like to maintain it for each version of the compiler over time. So the hope is that we will get pull requests saying, hey, this is what it looked like in GHC 9.6. Now this is what it's going to look like in GHC 9.8. And maybe we can eventually retire some older versions of it, and some testing infrastructure to tell us when things need updating would be a very welcome contribution, but we don't have it yet. You had a question?
Does the error message itself contain a link to these things, or is it a platform?
So the question is, does the error message contain a link to this page? And it does not currently do so. The number is the link, and you can get a predictable URL out of the number. So it's essentially, I blurred the URL up there because right now it's on a temporary address until we get the GHC branch merged, and I don't want people to bookmark the wrong site. But essentially the code appears as part of the address, and hopefully, as you're aware, coordinating with HLS people to get to use the URL field in the diagnostic item data type in LSP, which hopefully will allow various editors to present reasonable links to these things in line. And otherwise, we can look at various ways to do that.
Is there going to be support for more informative categories? Because currently it's GHC-whatever. Yeah. It would be nice to have GHC-var, etc.
So the question is, will there be more informative categories? The plan is not to do that right now. It might be interesting to add like a tag system to the data model here. I don't know that we can come up with, on the one hand, I don't know that it's that useful to sit there and like browse categories of type error message. The intended use case is that I get an error message that says, kind variable would escape its scope, and I think, what have I done? Like, this makes no sense to me. And then I go type this in, and then I see a more detailed explanation that says what's going on. I don't know that people are going to want to be browsing the error messages and just kind of see what's there, but if they do, then a tag system would be very nice. And if you want to make one, let me know. Otherwise, if I get some free time, I'll try to whip it up.
Is this mapping from the constructor of the error message types and the numbers, is this actually in the GHC source code and is programmatically available to API users?
So the question is the mapping from the constructors to the codes part of the GHC source code and available to API users? And the answer to that is absolutely yes, it is. You can go look at the open MR that Sam Derbyshire got up right now to take a look at the details of the implementation.
So I see that this error happened on line 9 of main.hs.
Yes.
Is main.hs preserved here somewhere? So
yeah.
Look at the whole thing. We generate it.
Yeah. So John asks whether main.hs with line 9 column 49 is available here. And yes, if you scroll down to the next screenful here, which unfortunately Simon cannot do with the PNG that I sent in from my laptop, then you'll see main.hs next to a version in which the error has been corrected. Richard.
So if someone wants to contribute, where should they go?
Richard asked if someone wants to contribute, where should they go? And that is on the Haskell Foundation GitHub site. There's a project called Error Message Index. Or poke me and I should have put the URL for that up here, but I didn't. But we'll make a bigger splash once we get the branch merged, because if we do need to go update all this data to get as part of the merging process, I would rather fix 60 error messages than 360 error messages. So we're waiting a little bit until we get it merged, but I hope that'll happen soon. All right. It amazes me that the most questions came on a website full of error messages. Thank you for your interest.
It's an indication of what's important to everyone, right? As someone who was puzzled over GHC's error messages myself.
Simon has contributed one.
Yes, error messages, in optimization improvements. This is all, it's working on 9.6. Better I/O, defaulting behavior. This is a sort of swampy area that Richard and I and Sam have been working on. And this lovely unsatisfiable proposal. So a lot of this is driven by GHC proposals. So this is just a little smorgasbord of what's likely to happen in 9.6. But actually, I think there may be other people who are working on things that they want to mention that might be in 9.6. Is anybody working on something that they like to be in GHC that they like to share with us? Loiter, for example?
I think someone wants me to say something about GHCI.
Go. Yes, tell us something about GHCI.
Well, recently I added support for unboxed tuples to GHCI, and there's just one more thing missing, which is directly doing foreign import prim in GHCI. I'm planning to add that for 9.6, but we can already load GHC itself into GHCI to help us debug our own compiler with the recent additions. So it's been, I think that's been in 9.4 actually. So yeah, that's the work I've been working on.
All of GHC.
Yeah, with all the unboxed types. And I have to admit that lefty polymorphism was a bit of a headache in GHCI as well. If anyone got seg faults because of unlifted data types, then apologies for this, but it should be fixed now.
Anyone else got anything they'd like to share?
Yeah. Are there any further changes to the record dot syntax coming up?
Yes. So the question is, any further changes in record land? Yes, actually, if you look on the GHC proposals site, there's a sort of collection of smallish incremental proposals around records. Things like, if we got duplicate record fields, how do we disambiguate? And you've got an occurrence of a field, how do you disambiguate? And how do we do overloaded updates? And Alan Gundry is typically leading these. So it's hard to say. There's not one big thing. There's quite a lot of incremental stuff that I think is gradually making the world better there. But it's partly incremental because it seems really the whole world of records seems like a swamp. As soon as you wander in there, you get sucked in. So the only way to move is to sort of move one tiny step at a time. But I think things are getting better. But it's definitely not stopped. Indeed, I spent 2 hours on Friday on the call with Sam Derbyshire working on actually it's an internal refactoring, but it will do something a little bit better in record land. Anyone else? Well, this is an open invitation. GHC is a big open source project, and we'd love to have your contributions. It is, as you've seen, a lot of fun. Now, where are we? Let me say, we're 10. Yes. Oh, sorry, Richard. Yeah.
A quick plug. So Simon mentioned.
Simon mentioned a few times that, about the GHC proposal process. I just want to advertise Joachim is running a session Thursday afternoon at Haskell Symposium where we can discuss GHC proposals. So if you want to come, I think a bunch of us will be there, and we can, if you have a proposal that you want to discuss and understand better, that's a good place to do it. Is that accurate?
Yeah.
Okay.
I guess my phone.
So it's a bit like a lightning session scheme, just focused on GHC proposals. I guess one would usually have the author of a proposal to come and say, hey, I want to do this, and then we have a discussion, but not all the authors are here. So if you have any proposal that you kind of care about, even if you don't like it, that you wanted to be discussed, then just sign up and say, we're gonna get everybody in the room on board what it's about, and then we can have a discussion. And we have plenty of spots left, so let's help us make this a good format.
You don't even need to have written a proposal yet. You could come and talk about a proposal you'd like to write, yeah? See if anybody cares. You just say error messages, and everyone will say, yes, that sounds great. But this is a little summary of the GHC proposal timeline, what's happened over time. So since the last Haskell Implementers Workshop, 143 separate proposals have been made to the GHC proposal process. That indicates some level of excitement and ferment and interest and development in GHC as a programming language. I think it's amazing. During that same year, 15 proposals were actually accepted, and 19 new ones were implemented. So we sort of implemented slightly more than we accepted, but we're still a bit behind because we got in total we got 106 accepted, of which only 59 are implemented. So there's plenty of opportunities for people who like to contribute to take some of these proposals that have been agreed. Said if anybody implements this, we'll put it in. And, the implementation doesn't turn out to be awful in some way. So plenty of opportunities here. Do you want to know which proposals were accepted this year? Here they are. I'm not going to read them all out, but they're here's the first collection, and here's the second collection. Oh, question marks is this some strange PowerPointism that I failed to correct for this. Not sure about that. So, fair amount of activity on the GHC proposal front. And the big thanks to everybody on the GHC steering committee who really, here they are, by the way, for whom looking at 143 proposals during a year is a pretty significant time commitment, isn't it? So I think we owe quite a big thanks to all of these folks for actually doing that, especially to Joachim for being our secretary, sort of trying to remind us when we have dropped the ball on something, which we often do. Thank you, Joachim. Let the record show spontaneous applause for I did want to say something about the Haskell Foundation, which has been just very helpful to have a forum in which to discuss cross-cutting concerns, like things where GHC sort of overlaps some other areas. So we don't quite feel mandated to decide anything or even to chair a discussion about it, but nevertheless it affects what GHC does, and what GHC does affects other people. So it's really helpful to have a place to have those conversations. And the error message thing is also an example of a positive initiative to do something that we'd love to see done, but lack capacity to run. And it's easy for people to contribute to without being hardcore GHC developers. So I think, from my point of view, I mean, I'm a bit biased, of course, because I'm on the Haskell Foundation board, but I went with a strictly GHC hat on. The Haskell Foundation has been a big help to us. So thank you very much to David and all the other people who've contributed to the foundation. On the board of just contributing to the various projects. What else did I want to say here? A little bit about the sort of GHC hardcore developers and that sort of HQ. So this is WellType's GHC team. Right. Actually, Brian doesn't work for, but I put him here because I forgot to change the title to just GHC team because this started off as being Ben Slide, and then I thought, but Brian is absolutely part of this core group. So very sorry about the title. Just delete WellType because in fact, though these guys work for WellType, but they're generally funded from elsewhere, as is Brian. So. Simon and I talk with this group every week about what's happening to GHC, and they work extremely hard. I'm very grateful to them all. I should, Brian in particular. Let me just say about Brian. So the Haskell Foundation is specifically funding Brian to work on the DevOps side of GHC, particularly to make sure that the continuous integration infrastructure works well. It's very discouraging as a contributor if you make a patch to GHC and the CI falls over in some way that's absolutely nothing to do with you. So that's a real help having Brian on board. A real help. He's been working quite hard on that. I think there's been a sort of startup curve in which he's trying to figure out what kind of failures are happening and why, and then what can we do about them. So I think we'll start to see more and more results coming out of that. I'm really pleased. The core team who are, of course, don't do all the work. It's a lot of volunteer contributors do all the work. And this is a little graph of how many actual distinct individuals, well, at least distinct GitHub accounts. Maybe some of you run several personae on Git, for all I know. So this is one or more commits. There's 1 dot per year. And in 2022, it looks as if it's going down, but I think that's probably because we're only partway through the year, right? At least I hope it is. And these are, as you can see, 1, 2 or more, 5, 10 or more commits. So there's a sort of steady, maybe slightly increasing number of contributors, but it's in the many tens for people who are doing something. And the door is wide open. Please, please do join us. I'm going to suggest ways in which you might. And here's a reason you might want to join us. This is cumulative tickets. So this orange line is the number of tickets opened, right? So quite a lot of them, of course, have been closed. But the blue line is the number of tickets that are still open. And there are a lot, nearly something in the region of many thousand open tickets. So this is quite a challenge because, if you think, what shall I do today? You think, well, I could do any one of these 4,500 tasks. It's a bit daunting. So keeping track of all this, that's what Matthew is as sort of project manager, but is in charge of doing. But it means there is plenty to do. Plenty to do. And I think this happens to every major project. And there's an immense collection of. I look back in the through tickets. And find a ticket that's 3 years old. And I think, what's going on here? And then there's a sort of long screen. I say, oh, it's for me. And look, I have no recollection of writing this. Complete nonsense. 2 projects, again connected to the Haskell Foundation, that is being thought about by the Haskell Foundation Stability Track. But I thought I might mention here because I'd like people's opinions about them. Yes.
Can you just back up to the tickets for a second?
Yes.
What do you imagine the end game is here? The more open tickets you have, the more difficult it is to manage the set.
Yeah, that's right.
Unless you know what's going on.
Yes.
Is there some sort of effort to close some of these?
No, not really. So Norma's question is, what's the end game for this? Right? If you have 5,000 open tickets, how can you even find the ones that are important or interesting? So there's milestones, right? So tickets, we look at milestone tickets. If it says milestone 9.6, we make sure we deal with all of those, possibly by milestoning them before releasing 9.6. Right? So that's one mechanism. There's sort of priority scheme, and is it how easy, hard, or difficult it is. But the truth is that we don't have a systematic way to get them closed, because you look at each one, you think actually it's a reasonable point. Some of them, quite a lot of them are just, well, yes, that's not an unreasonable idea that you got a bit stuck there. That's just the way it is at the moment. So. But it's a lot of work to systematically close them. So no, not at the moment. But be my guest.
So if you could, next time you have a chance to talk about this, it would be really good to see what you're actually looking at, whether it's milestones or priorities or whatever. This tells a very discouraging story. It would be good to know what the real story is.
So the real story is that the milestone is I think the only thing that's seriously looked at, and what that means is that recent tickets, ones that have, human brain cell mind share, tend to get a lot more attention. So that does mean if there's a ticket that matters to you, right, then pinging it and saying, this matters to me, you'll put it on the ticket and, would it be considered for the next release or could we talk about it? That's really worth doing, because anything that hasn't been talked about recently is quite likely never to be talked about. So that's the main end game, is things die of old age rather than that.
Do you have a feeling for how many tickets are duplicates or overlap?
No, so some of these are duplicates and overlaps, and some of them are marked as such. Sometimes people close duplicates, but in some ways I don't like that, because that looks as if it's dealt with, and it isn't really. So I think practices. So there's quite a lot that are duplicates that we don't know about. There's probably quite a lot of duplicates that we do know about, and some of them have been closed because they're duplicates. But so really they're still open in a sense. They're reporting a live bug, but it's the same bug as something else. But I wouldn't think that I don't, even if you systematically eliminate every duplicate, I don't think it would move this needle very much. It's my instinct. Okay. I'm conscious that how are we doing for time? It's quarter past, is that right? Just let's say a little bit about this is sort of cross-cutting, concerny kind of things, which I'd love to know your opinion about. We could talk about this now or later. This is to do with how GHC impacts the rest of the community. So one thing that we noticed is that when we make a release of GHC, if a library author wants to update their library to, let's say, GHC 9.6, they have to wait till their dependencies, the libraries they depend on, have been updated to 9.6. And that library author has to wait until their dependencies are updated. So there's a sort of fairly slow process in which the libraries at the bottom of the stack get updated first, and then maybe the libraries, the authors next up, wake up one day and discover somehow that all their dependencies now have been updated, and they wake up and do their thing. But it can take, a year for this to propagate through the system. And it's very dependent on not only that places an uncomfortable burden on library authors because they need to do this sort of polling mechanism and wake up at the right moment, and they might legitimately be otherwise engaged. But it also means that the library authors become a kind of single point of failure. A single library author who is, for whatever reason, perhaps a very good one, unavailable, can block the entire dependency tree above them, which, if they're a popular library, could be quite a lot. So this proposal was about, could we do anything to ameliorate this? Now, the exact mechanism for doing something to ameliorate, maybe some of you have better ideas. The mechanism suggested here is to use what's called a hackage overlay, which essentially means that you can point Cabal at a so-called hackage overlay, which means it'll download packages, the packages plus little patches that other people, maybe not the library author, have offered to fix the package for that version of GHC, right? So it's a bunch of patches to packages, which means that third parties can build patches that make the package work that aren't a proper release of that package, but by pointing to the overlay, you get all of the benefit of all of that. Right? So that means that library authors can update their, they could update their own package, but they could also update the packages they depend on if they like, or wait for somebody else, or we could have a big party to do it. That's the kind of idea. Read about it in the proposal. I'd love to know if this is the right thing to do, if it's even a problem for you, if there would be a better mechanism for getting it done. And this is a good example of where I think the foundation is very helpful, providing a place to have that discussion. I mean, we GHC, we want to know the answer. We want to do whatever will be helpful. Very conscious of this, that we don't discover that shallow subsumption is a problem for 9 months. That's absurd. We ought to be able to do this more quickly. See the problem? So anybody got any, I mean, we could talk about it during ICFP, but if anybody's got any immediate thoughts or reactions, I'd be happy to hear them. Yeah.
So as an HLS contributor, I can say that this is a problem for us because when a new GHC version is released, we want to release a new HLS version that supports it, but we cannot do so until our dependencies
have a lot of
updated. And we have a lot of dependencies, and that's the reason that HLS releases lag behind GHC releases, and that also hampers the adoption of new GHC releases, the fact that there isn't an HLS version that supports it. So this is a valid solution. I don't know if it's the best solution, but it certainly helps us.
Yeah. Okay.
Do you have an idea of why it seems that every new release breaks so many things? I would expect that not so many packages break, but it usually turns out that every new big release kind of breaks some vital part, which then, as you said, propagates throughout the whole thing.
No, not really. I mean, I think the deep subsumption thing is an example, right? Which you are personally involved in, right? You're complicit in this. So the truth is, nowadays we make truly strenuous efforts to avoid breaking things. But there often is a tension between about, this is about perpetuating a bad way to do things. And so actually, yes. So despite strenuous efforts, it still seems, particularly for packages which maybe inadvertently depend on some more internal aspect of GHC. But even then, right, even if there's no breaking, even if a library author needs to make no changes, they need to update the version bounds on their imports. They need their dependencies to be updated. And so at some point, when you get further down the stack, you get more intimately coupled to GHC, the ones at the bottom. But yes, I suppose one possibility is to do what Go does, which is to say, we will make no breaking changes, right, as a matter of policy. And I think I don't think, well, I'm not happy to do that for GHC. I don't think, I hope that you aren't either, maybe some point, which we do that. But that would be the logical conclusion of, because it's undoubtedly disruptive. Yeah, sorry.
Actually, my point was a bit going on that, whether it's actually GHC's problem, apart from its assumption, of course, but or it's actually the fact that everybody has to update their version. So it's a bit. This is great, but I'm a bit worried that the problem doesn't really lie on GHC's side, but more on the fact that everybody has to update their bounds, and this has to propagate, which is a different problem from this one, I think.
Yeah, so you could say it could have weak, looser upper bounds, right? But that has its own problems. That's a sort of big library sort of design choice as well. And something like that Arrayhash, the thing that I was describing, that's an API change. It will only affect bottom level libraries, but it does make things better. Yeah. So yeah, Richard.
So you mentioned Go as something that they don't make any changes. Everything is backward compatible. There is a sort of a middle ground, which is what Rust does, which is that they make changes, but that I think someone can correct me if I have this wrong. But you can sort of label a file as to which version of Rust it's meant to compile against, and then so the Rust compiler guarantees to always support all previous iterations. So the sort of the tip. You can keep doing new things, and you can change things, and you can be backward incompatible as long as you maintain the implementations in perpetuity for everything that came before. I'm not saying that that's a good idea necessarily, but it's another way to crack this nut.
Yeah. It would be hard. Again, imagine that Arrayhash thing. It would be really yes, Alex.
So for what it's worth, I recently had the experience of updating a couple of relatively large Haskell projects to newer versions. And my experience was that overwhelmingly the work was not changing. Like there were some minor changes I had to make in the project itself, but it was mostly in project's dependencies. And in particular, there were a lot of changes that I felt like were really sort of silly because packages just depend on random guts in GHC exts or primitive and things like that they really probably don't need to be doing. And so I think to some extent, it would probably be valuable to try and identify subsets of things that are used in a bunch of different packages and somehow consolidate and provide some, compatibility API that is more stable. And I think that would probably help relatively significantly.
There's another GHC proposal about that, which Richard and I wrote recently about, particularly for GHC, trying to identify which parts of GHC's big API is meant to be stable, that is, its advertised permanent interface, and which parts are internal, accidental things that, like mapFB is a function that happens to be defined in GHC base. It's part of the Fusion framework. It's not expected to be called by any user, but you could import it and use it, and then you shouldn't complain if I change it, right? Because it's really an implementation artifact. At the moment, we have no good way to delineate that. So that's another conversation. Delineate the stable API of a library from its unstable API. That's another. Look for a GHC proposal about that. Let me move on because we're going to run out of time. But this conversation, the one about the stable API, and I think this release schedule thing are all things which affect a lot of people. It's difficult to kind of get right, and I do think I personally would find it very helpful if we collectively, not led by me, but maybe led more by the foundation, or somehow came to a consensus that told us what to do. Because I feel as if we're floundering a bit in this space. On release schedule, we talked quite a lot actually at this meeting in past years about GHC's release schedule. Rust has a very aggressive release schedule every 6 weeks. GHC used to be sort of annual, then we moved to 6 monthly in response to requests from people here, I think. And of course, the faster you release, that's it's you get more churn, but of course you get more stuff quicker. And it does cost something to make a release. If it's slower, though, you release less often. You get the contributors dislike it because they think, it's going to be another 11 months before my feature gets in. And if they think, I'm so nearly ready, can you just wait a moment? And then because otherwise it's going to be a year. And when you're 64, a year doesn't seem very long. But I remember when you're 22, it seems like forever. I really want it. So, okay, enough said. So, Ben's suggestion was, which is something we're actively thinking about, but doesn't seem to have been received it has not received fulsome support, this idea, was to have or to alternate releases with one release a year that we say we're going to maintain this longer term, right? So for we need to specify what longer term. That means we'll backport fixes to this release for a longer period, 4 years or something, or some major releases. But then the alternate 6-monthly release, we won't support long term. It'll eventually be completely flattened by the next tick release. That was meant to, because of course the more releases you have, the more people are saying, well, I'm using 9.6.7. Can you just release a backport some crucial patches to that? So there's a proposal about this. Here's the link. Do please tell us what you'd like. I would really like to know. And if only 3 people contribute on these, on the links. Oh, isn't there not a? Oh dear. Yes, here's a link for this one. If only 3 people speak on these things, we won't get a representative voice. So I would like I sense that there's quite a lot of people who are active Haskell users and library authors. Please, say something on both of these proposals. David.
I also know that participating in GitHub discussion threads is overwhelming for many people. So if you don't want to do that, you can email me and I'll summarize your comment and you won't have to think about it again.
Okay, thank you for that, Alpha. Yes, or just buttonhole him. He's here in person. But don't tell me, tell David, because I'm a poor conduit for this kind of stuff. I'm wrapping up. Good, which is a good thing, but we have 6 minutes. Is that right? Yeah. Good. Hadrian is the result. I got a message from Andre when we did the switchover. He said, this has been a 6-year journey. Andre Bokov, who was responsible for the first version of Hadrian. Andre, are you there? Andre, tell us about your yes. Tell us about Hadrian. Just because it's a watershed moment, right?
Yeah, I just want to share, correct you. It's 8 years, not 6 years. Yes, and it was like my personal impression was changing from we are going to be able to do it in a month to we're never going to be able to do it, but finally it's done. So I'm helpful to all the people you mentioned who help with help maintain GHC and Ben and Matthew and everybody, because they actually completed the last 3 months of journey when I was no longer able to continue myself. So thanks to everybody, and I'm super happy this happened.
Well, I did a line count on Hadrian and compared it with line count on Make, and I have to say it was the same. But we did not have $, which was the extraordinary thing we had in Make. It was truly amazingly unmaintainable. So, but now it's had a big effect on Andre's life, because now Andre's working on another build system at Jane Street. So, so it was not a small thing. Okay. So I wanted just to finish by leaving a slide with, is this this? Yes, this is essentially my last slide. GHC is this big open source project. It's massive. It's 32 years old, and it's still vibrant, as you will see, if you have seen today. So, and it's the result of lots of people's efforts, and I'd love for more of you to get involved. And I think increasingly there are ways in which you can get involved that do not require you to become an expert in category theory. Or know how coloring register allocation works. You can just contribute one new error message documentation thing, or you can help with the conversion to rich errors, which is converting those SDocs into data constructors, or you can help us with compiler performance. So now we've got these new profiling tools. There's lots of. I don't think the fruit is low hanging. There's medium hanging fruit. I think we've got all the low hanging, we profiled the compiler and all the things that are easy to fix, we fixed. But but I think there's plenty of medium hanging fruit on GHC's compile time performance that some close attention with good profiling tools could improve. So lots of things to do. Anybody got any other observations or comments or questions they'd like to make? Yeah.
I was hoping I could do a quick update on Cabal.
Yes, please do. Yes.
So I wanted to give a 1-minute update on Cabal. For those that don't know, over the past 2 years, we've had basically a complete overhaul of the maintainer team of Cabal, and we've got a whole bunch of new maintainers, active contributors. We have a bi-weekly call that people hop on, that you're welcome to hop onto, where we talk in person and we plan stuff. And if you interacted with Cabal before and now, it's totally different. every ticket people are really nice to you on, okay? And we really, every time you open a PR, people bend over backwards to try to figure out how to solve it and how to merge it. So it's a very different contributor experience and commenter experience. And there's a couple features in 3.8 that are really good that I want to highlight. So if you've used scripts before with Cabal, they're really cool, but you have to recompile the script each time, which, you know, made it not so pleasant. Now we have caching for that, so that makes scripts much more usable. If you've been interested, if you're like, oh, Cabal syntax is a pain to parse, the Cabal syntax library has been split off, so you can just depend on that and use all of those data structures without depending on anything else. The Cabal solver library has been split off if you want to explore this using the solver or changing it on your own. A couple things that yes, multiple public and private sublibraries now fully supported. You still can't upload the hackage, I'm on it, but outside of that, now we're encouraging that as a broader feature for people to really put to use finally. Couple things I've been more directly involved in. You can, in your Cabal.project files, you can import other Cabal.project files, including ones that are remotely at other URLs. And since a Cabal.freeze file of the sort that, say, Stackage provides, where Stackage LTS is a Cabal.project file, you can import Stackage into a Cabal.project file and get your Stackage dependencies through a single line import. It also opens up a lot of other things, and these imports can be guarded behind a new feature in Cabal project files, which is conditionals. So you can have a Cabal.project file that branches conditionally on machine architecture rather than a different Cabal.project file for every machine architecture. So that's another very nice usability improvement. And finally, in test suites, often there's a lot of things that have discover style tests that, or sort of walk through and generate code that they want to then be part of the test suite by inspecting the source code. In the past, this was very hard to work with new build. Now we have a code generators field. So you can write a driver that will walk through your source files. It will generate new modules, emit them, and then it will tell Cabal, here's all the new modules I've admitted. And then Cabal will go back and recursively then compile all those new emitted modules. And that means that a lot of the workarounds that you needed, you know, the test generators need to be updated to make use of this new feature. But it should make integration with Discover style tests much more natural. So I want to encourage people that do test stuff to take advantage of that. That's the quick rundown. But anyway, we're very welcoming to PRs and new contributors, and there's a lot more cool stuff coming. But there'll be even more if you wanted to join in on the effort too. So thank you.
Great.